Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Hey y'all, happy new year. The last live Q&A of 2023. And here's hoping it's going to be a good one. The topic today is something that is not normally talked about. I mean, it's mentioned in passing, and one of them I don't know that I have ever seen discussed, but we're going to change that today. Before we get going, however, I want to give a shout out to a couple of people. We do some behind the scenes housekeeping here. And the first one, as usual, to my buddy Steve at Harneal Media. Now, if you're running a business, if you are, whether you're creating vector files or 3D models, or if you're creating projects to sell, there is no better way than with a website, with a web store on that website. And this eliminates that Etsy middleman or your that third party website that you're paying commissions to and what have you. Believe me when I say Harneal Media is the only company that I will ever recommend. I mean, as long as Steve's in business, he's got my vote. He is very, very good at what he does. How he does it all, I have no idea, but he does. He will do as much or as little as you would like. If you are a seasoned veteran and running a website, he can just sit in the background and keep everything updated and let you go. If you need hand holding like I do, he can cover that as well. He is very, very competitively priced. He's a small home based business, but don't let that fool you. You will get professional quality and professional results. And you can ask a few people here in the chat joining us right now. Um, I consider him a good friend. You're going to get 100% personalized service because when you deal with Harneal Media, you deal with Steve, and that's it. So he is the sponsor of Mark Lindsay CNC.com, my website, which needs updating. And there's a link to Harneal Media in every video on my YouTube channel. Check him out. You will not be sorry. Harneal Media. The next person I'd like to throw a shout out to is my buddy, Bull Shanigan. Now, I get asked a lot if I do one on one training or one on one tutoring. And the sad truth is, I just do not have time to do one on one training. There just aren't enough hours in the day for me to take care of everything I need to take care of around here. But my buddy Bull Shanigan, he does. He's very good at what he does. Now, there's a link to Bull's website down in the description of this live stream and my past few live streams. And if you go over there and check it out, he offers one on one training. He's, again, very good at what he does. He's got a very smooth, easygoing demeanor. He doesn't, he's not a taskmaster or anything like that. And you'll not only get some good instruction out of Bull, but you're probably going to make a real good friend too. I'm proud to call him a friend. And there's a link to his website down in the description of this live stream. There's also a link to his Facebook group called The Make. That's a tidy little Keebler tree over there with some very talented people. And I would encourage you, if you're on the Facebooks, get over there and join The Make. There's a link to it down in the description of this video as well. I tell you, that the talent that exists out here in this community, it's it's um it's mind-boggling sometimes. Some of these people you don't hear a lot about. Some of these people you do hear a lot about. Um, and I think we need to be boosting and we need to be supporting the people in the community that support us. And it's real easy to find these big nameless, faceless uh, corporations and companies and what have you. But Yeah, they may provide services, and yeah, they may provide products, and I partake in some of their products or services, but it's very rare that you will see them come into the community like you do with Steve, and like you do with Bull, and like you do with Michael Mazalik, and so many others. We need to support the people that support us. We need to support the people who are a part of this community and not just somebody out to make a buck, you know? So I know it's really, I know it's really cliched to say it, but support small businesses. Now, Wendell has I'm guessing this question is to Steve. Does he offer a credit card portal? Reach out to him. Reach out to Steve through Harneal Media, and that's some of the nuts and bolts kind of a thing that you'll have to talk with him about. So uh, I won't say yes or no simply because I don't know. But I have never had an issue. I believe. Well, I'm not going to say anything further. I believe he does, but I won't go any further than that. So let's go ahead and get into today's topic. And as you asking questions, I am marking them and saving them for later. We'll get to them after we get into today's topic. But believe me when I say yes, I will get these questions and we'll get them answered. So let's go ahead and jump right into Aspire. And let's get into today's topic, and that is vector boundaries. Now, uh, I'm sure a lot of you who have done any kind of 3D work at all have already used a vector boundary when it comes to 3D. Okay, let me stop for a second. Would someone explain to me what's a Keebler tree? Okay. Al, I sometimes forget we have people overseas or people not within the United States who are not familiar with American slang and slogans. Um, a Keebler tree. Keebler is a brand of baked goods here. We're talking cookies and um, donuts and crackers and things of that nature. And the Keebler advertising is they're a bunch of elves who live in a hollow tree and bake all their goodies in that hollow tree and then put them out on the market for sale. And some of their big the some of the emphasis in the Keebler elves is they're happy, they're friendly, they're efficient, their stuff is good and good for you. How much of that is true, I don't know. But saying somebody runs a tidy little Keebler tree is making it's using it as a euphemism for someone who runs a very tidy ship and who's very competent and knows what they're doing. I'll stop using that because yeah, but it is a fact. So, what can I say? Okay, into vector boundaries. Um, most uh, most times we use vector boundaries, and the only time I've ever seen them mentioned is when it comes to 3D projects like this. So I've got Wally the Gator out here in the middle of my material, and a vector boundary in this case is usually used to draw a vector all the way around the model to use that as a machining limit. I only want to machine this. I don't want to machine anything out here. And I don't want to add to the machining time by trying to machine the entire piece of material. So we'll go over to the modeling tab and we'll make sure that our model is selected. And then right here under modeling tools, we'll go down to the third row, the fourth icon, and it says create a vector boundary around the selected component. And I'll click that. Then you'll notice a little bit of a jump over here. But what has actually happened is a vector has been drawn around that model. And when we go over to calculate our roughing or our finishing toolpath, we can set that. Let's go ahead and go over to 3D roughing. It's going to go into material setup. Okay. All of that is good. All that's fine. When we go into our roughing toolpath, we'll machine to the selected vector and make sure that that vector is selected. Then I'm not going to change anything else here. I'm just going to go ahead and take that as whatever it is. And we can see that the only thing it's going to carve is right there around the model. It's not going to bother with anything out here. Now, I venture to say about 90% of you already knew this. But there are a few who might want to know that. Now, let's go back over here into, whoops, let me close this and uncheck that. Let's go back into the toolpath. We have several options here. We can do just the model boundary, meaning the entire alligator, but nothing else. But something to remember that a lot of folks forget is that if you have added a zero plane to your project, that zero plane is part of the model. And the zero plane is going to cover the entire surface of your material. Now, most commonly we'll use a zero plane if we're carving a dish. So if you want to go ahead and carve all this here, you certainly can. You would just use the model boundary or the material boundary. But if you only want to carve this area right here, that's when you would use that selected vector. So vector boundaries around 3D objects are more or less pretty self-explanatory. But something I have, and if you have any questions along the way, feel free to chime in and ask those questions. But something I have yet to see discussed really is over here in the drawing tab. If we come into edit objects, we go down to the third row, the fourth vector in, or fourth icon in, you can create a vector boundary around 2D vectors as well. And that's worthy of some exploration. So let's say, for instance, you want to create a cover. You need to carve a cover to go over something. And you have holes that need to be drilled all the way through the material for some bolts or screws. And you need to draw that cover out. Now you've taken some measurements, and this is just an example. You've taken a few measurements and you know you need to do 1/4 inch holes or about 6 millimeter holes. Well, let's go ahead and let's draw this thing up. The first thing I'm going to do is come over here and to draw a circle, and I'm going to draw my mounting holes because I know the center of where those mounting holes need to be. So I want them to be 1/4 inch or roughly 6 millimeters. So I'll go 0.25 for my diameter. And I know they need to be about 4 inches apart. They need to be 4 inches apart. So the first hole I'm going to create, I've got my XY0 set to the center for layout purposes. So the first X, I want at -2. And in Y, that's going to be +2, let's say. So that's going to put the center of this 1/4 inch circle right about here. Let's create. And there we go. We have our first circle. That's going to be our through hole. Now we need another over here. The only thing that's going to change is I want it at +2 instead of -2. So I'm just putting the through holes in right now. And we'll go over there. All right. Well, if it's just a square cover panel that we're making, then this gets pretty easy. We're going to go to -2 on my Y, +2 on X. That's going to put one down here. We'll create. Then I'll go to -2 over here. And that's going to put one on this corner over there. Create. Okay, pretty straightforward. Now, we also need to counterbore. We want another circle around these that are 1/4 inch larger than these holes. We want to drop a washer down in there, and we need the heads to be down below the surface of the material, the heads of our bolts. Now, we could go in and draw bigger circles. We could go in and offset these, but there is another way, and that is we'll select all of our holes. Then we'll come over here to create a boundary vector around these selected vectors. So I'll click on that, and that opens up this form here, vector boundary. Now, what I want to do is I want to do an offset boundary around these circles. And I want it to be a total of 1/2 inch larger. Okay. So I'm going to go for a distance of 1/4 inch. And I put a second decimal in there, which Vectric does not like. And I'll go ahead and I'll create an offset boundary around those 4 screw holes. Okay. So I have, let me zoom in a little bit here, and I'm going to come to my measure tool. So I now have a counterbore, and I'll measure the distance from there to there, and we see that that is 1/4 inch larger all the way around. Okay. Now, Bull is asking, what's the difference between a boundary offset and the offset tool, or is there? Well, I'm getting ready to show you. Okay. I'll show you the main difference, because yes, you're absolutely right. You could simply choose these 4 circles and offset them individually. Here's where the cool part comes in. So now for the size of your panel, the panel itself, you need it to be 1/4 inch larger than the outside of these 4 circles here. You need a 1/4 inch border, and you want to draw a vector around the outside, and you want rounded corners that kind of matches this radius. So what you'll do is you'll select these here, and I'm just holding down Shift and selecting each one. We'll go back up here to draw a vector boundary around the selected vectors. Now we still want an offset boundary. We still want a distance of 1/4 of an inch, but we want to draw a rubber band boundary around all 4 of these. And what that does is that will draw a vector around all 4 of these using the same radius, and it will make no attempt to weld these vectors together. It's not going to try to follow contours or anything. So if I go create, I now have my cover plate. The distance here to here is that 1/4 inch. Same here, same here, same here. Grab my measuring tool. Let's get in and let's make sure about this. And I'll just start right here, go to right here, and my distance is 1/4 of an inch. Okay. So let me undo that. Let me Control Z. I'll undo that. And let's just say, for purposes of discussion, that we don't want a perfect square. That these two right here should actually be an inch over. So I'll go into Move Transform mode and I'll drag them over an inch. Now I'll select these outsides here. Again, Shift. This is just one example of how this can be used. Come back up to do a vector boundary. Again, I want an offset boundary of 1/4 of an inch, and I want a rubber band boundary. Then I'll create that vector boundary, and there is my cover plate. Then I quickly discover that there's a bolt hole supposed to be down here. Well, oopsie. Let me select this bolt hole, put it into Move and Transform mode. I'll hold down the Control key, and I'll drag a copy. Let's base it off of the center on this one, and we'll put it right about there. And I'll delete that boundary. So now I've got this weird looking pattern that I need. I can still go back in here, and then I can start getting creative with it. I can still do a rubber band boundary and create that cover panel. There are all kinds of options. There are so many different permutations. I don't like this diagonal line. I'm going to fix that. So I'll Control Z to undo that. And what I'll do instead is I'm going to just select those 4, do a rubber band boundary around those, create, okay. Then I'm going to select these and do another rubber band boundary around those, close. Now I'll select these 2 and weld them together. Fillet, oh, nope, wrong one. I chose the fillet tool. There's weld. Hello. I got to select the vectors, Mark. All right, let's weld those. Let's try this a 3rd time. Boom. Okay. Well, that looks a little strange. I got this little cutout here, but I can fix that. I can go into node editing. I can drag this. Now, first let's make this a line. There we go. Now I can drag this down to where that's 90 degrees right there. delete that point because I no longer need it. Come out of node editing. Now I can do a fillet. And boom, there we go. There are all kinds of examples where doing something like this will work out. I mean, great. It and it's there are all kinds of situations where something like this could be used. Let me go ahead and select this, put it on a new layer. And I'll keep layer 2, and I don't want it visible. There, it's not restricted to closed vectors. It can be done in many different ways. Let's say you have a line here, and we have a line here. Now, these angles aren't anything that I have, they're just a couple of arbitrary angles. But now I want to draw a vector boundary around that. I can come back over here for the vector boundary, and I can turn off rubber band, and I can create a closed vector around those two open vectors. Or, Control Z, I can do a rubber band boundary around just those two vectors right there. And there's my shape. And that can be offset and used for V-carving. You know, or for, yeah, I can offset that. Let's go ahead and do that. I'll offset it outward. Let's go with a 1/16 of an inch and offset that outwards. And there are two vectors that I can V-carve in between. Now, when drawing, are sound effects helpful with designing? I find they are for me. I sound like a pinball machine or a popcorn popper while I'm designing and drawing. Bada boom, bada bing, pow pow, bang, whatever. The important thing is you have fun. I mean, and you can get all kinds of different shapes and designs and sizes when you're doing this. I mean, it's a cliche to say it, but the limit is your imagination. Now, it's not applicable in every case. I mean, sometimes that, for instance, that cover that I was just talking about, um, maybe the outline of that cover is the most important thing. So, and then you have to come back in with all the various measurements. But if you're creating a project and certain elements are the focal points or the features of that project, um, like these, it's more important that these through holes and these recesses be in these places, and the outline shape doesn't really matter. Well, then it's a viable option. So we would take this over. I would select these 4 through holes or 5 through holes and select the drilling tool path with no, let's go with a 1/4 inch end mill because that's what I have. Yeah, I'll use a 1/4 inch roughing end mill. We'll select that. I want to go through the material, so we'll go Z equals, and I'm not going to use peck drilling for this demonstration. Calculate. Now I'm not going to preview it just yet. Now I'll select the outside vectors. I probably should have grouped these so I would only have to select one, but what fun would that be? And now for this pocket, let's go with a 1/4 of an inch. That's fine. About 6 millimeters roughly. I want to remove that bit because it's just not necessary. And I'm going to offset these because it is a round vector. And we'll calculate those. And I'm not going to preview just yet. I'll go over here and select this. For that, I'll do a profile toolpath. I'm going to cut all the way through the material. I'm going to edit passes for purpose of this demonstration. I'll do it in one pass. I would not do that, but for this demonstration, we don't want to watch a bit go round in a circle. There we go. And this is good enough. I won't add tabs for purposes of this demonstration. Calculate, and now when I preview all of the tool paths, get rid of the waste, we see I've got my little cover panel with the through holes, with the counter bore that's going to recess that washer and that bolt head, and then my profile cutout is self-explanatory. But it literally takes long to explain this than it does to actually do it. It's really a IL says, I think this rubber band concept is called a convex hull. It may be. It may be. I'm not really familiar with a convex hull, but okay, I learned it when I was modeling for very short type using OpenSCAD. Okay, all right, yeah. I hesitate to say that there's no standardization in terms because we all know that there is, but some of these things, some of these terms are regional. I mean, woodworking is pretty universal, and I'm just speaking about general woodworking now. But you have, for instance, the difference between a rabbet here in the US and a rebate in other English speaking countries. Then you have, we call it a planer and you call it a thicknesser. We call it a jointer and you call it a planer. Both, I think, are correct and both make perfect sense. It's just a regional difference in the language. I'm sitting here gesticulating with my hands as if you could see. But basically, the rubber band nickname comes just basically it's following the trajectory of whatever it is you're trying to surround, whatever you're trying to offset. And it's but it's maintaining that distance, that offset amount that you entered, that offset boundary, that distance, it's maintaining that distance. So now, yes, it would be very easy to do the math and say, okay, I want it to be a 1/4 inch away over here. I want it to be a 1/4 inch away over here. I could make this out of 2 rectangles. I could make it out of 1 and just add a bunch of nodes. Or you could just select them all, do some welding, do a little bit of node editing and be finished with it. It eliminates a lot of math that maybe you don't need. Let's see. And now Dwayne says, now if you needed a small lip on the underside for inset, would you use the offset boundary again? You certainly could. Are you talking about a small lip inside? Or are you talking about, oops, I'm pointing at the wrong screen here. Are you talking about inside of the profile or are you talking about one of these uh, counter bores? Because both of them could be done. You could, let's see, select this, do a boundary offset, and let's say I wanted to come in 1/8 of an inch. I could come in 125 and we'll make that negative 125, a rubber band boundary. And because I made the modification to it, it didn't follow this contour. This is a time where using, let's close and Control Z this, if you needed that offset inwards, you would want to use this offset. Okay, you would want to go inwards, negative 0.125, because, and Bull, as part of your question, this is where the offset would follow this contour, where the rubber band border would not, or vector boundary would not. So I don't think we have any sharp corners. Don't need to delete the original. We'll go ahead and select new, and we're doing an offset. There we go. So now you could um, use these two. You could, well, you could either pocket that or uh, do another profile cut here with a, let's say, a 1/8 inch deep profile. So the rubber band offset boundary here will not follow the contours of this profile. It will simply draw a vector all the way around. So, okay, undercut on a two-sided project. All right. What you could do for that, well, there you go. You've drawn this. I would probably, yeah, I would do this as well. I would probably copy both of these. I don't have a double-sided project in my job setup. So let's make this double-sided. Okay. I say okay. The computer is, there we go. All right. I would probably select both of these and copy to other side. That way you have them there on the bottom. Then you could do your undercut. And personally, on a two-sided project, I tend to do my outside profile on the bottom. So, yes, Wendell, you could do a lead in and lead out with a keyway cutter. But suppose you had, and that would make it a single-sided project. You could do that. Depending upon the thickness of the material, you could probably get away with doing that with a keyhole bit. But again, depending upon the thickness of the material and your keyhole bit. But yeah, on a two-sided project, I would probably do these two machining operations last on the bottom side. You know, and it, to your point, Wendell, you could do the keyway cutter, but for example, if you had artwork or something that else that needed to be put here, you could do this in conjunction with all that other artwork. Say you wanted to put your logo on the inside of this, you could carve your logo in this, swap out for an end mill, then cut your recess here, your undercut, then do your profile. So yeah, I mean, there are many, 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 many options. So, this whole thing about using the vector boundary kind of came about by accident, but I can't recall. Maybe you can correct me if I'm wrong out there. I can't recall ever seeing this explained in any of the videos, any of the training videos. And I, for the life of me, I can't figure out why, because it is something that would have come in handy on a lot of different things that I was trying to design or come up with. So, you know, get in and play with it, have some fun with it. It opens up a lot of possibilities, and it just makes things easier, eliminates a lot of math. So let's get to some of your questions here. And if anybody has any questions on anything we've talked about, um, by all means, put them in the chat. So, in no particular order, John Parker says, "What type of wood is that on your spoil board behind you, Mark?" Um, excuse me. If you're talking about that right there, that is part of a shipping crate that I got some parts in, and the top two pieces are white oak, and the rest of it is all pine, fir, cedar, something like that. So it's just some scrap material that I'll probably be using for prototyping or what have you. I've already got a bunch of it, but you know, free is always a good price. That is XPS, extruded polystyrene. The white thing on top of it is a piece of HDPE. The white thing on top of that is a silicone mold. That is a cedar fence board, and underneath it is a piece of MDF that I'm going to be using for a sled, and that will be the next project. I've been saying that for months, but I do mean it. So, okay. Let's see. Dwayne says, I suppose you will export the cover as a model and 3D print. You could, or you could be machining aluminum, or, you know, if it's like a recessed panel on the back of a desk or something like that, you could, you know, for covering a terminal block, if you had a bunch of different low voltage electrical connections or something like that. I could see it being used under a cabinet if you're putting low voltage lighting under some cabinets and you want to tuck away that power supply. So you don't have this big nasty looking thing stuck underneath, sticking to the underside of your cabinet. You could put a little cover over it. All kinds of different um, applications. And oh yeah, you certainly could export that and 3D print it. So let's see here. How would you handle the two-sided aspects of this project? I mean, how would you re-zero after flipping the part? I'm going to defer to my other videos on two-sided machining, in that's why you use guide dowels. And the thing that I see that trips people up most in two-sided machining and getting your zero set is they'll flip the part and then reset their XY0. And you absolutely should not do that. If you're using the locator dowels, and I will link my two-sided machining playlist again as soon as we're finished here. I just wrote a note to myself to put that playlist down in the description of this video as soon as we're done. If you're using those guide dowels, the minute you set your XY0 for the first side, then you don't change that XY0 for the rest of the project, because every vector was drawn based on that XY0 on the top. And if you use those alignment dowels as instructed, when you flip that piece over, be it top to bottom or side to side, whichever you have it set up in your job setup, let me bring this back in here. When you go into your job setup, you enter your flip direction. And if I have this set to flip from side to side. So I have to remember when I flip my material out on the machine, I got to flip it side for side. Those alignment dowels will keep it all in alignment. It works, and it's worked every time I've used it. In fact, that's the only method I use. I know some people come up with elaborate jigs for holding onto materials, but even using those jigs, that relies on you making sure that that piece is absolutely perfectly square and that your design is perfectly centered. Because if it's off in any direction, your front side and your back side is not going to match up. So, it's something to be taken into consideration. Now, using those alignment dowels, your piece of material doesn't have to be square at all. I've used cutouts from other projects that were of odd shapes and odd sizes. But once you set that XY0 for the top side, you don't change it. That's where the XY0 is going to be for the entire project. The only thing you'll change is your Z0. And again, I get into that in detail in the playlist. There are a couple of different two-sided machining projects in that playlist, and I'll put a link to that playlist in the description of this video as soon as we're done. So, let's see here. Brooks Martin is asking, do you think a drag knife will handle 1/8 inch rubber gasket material? Sorry to disappoint you, but I have never used a drag knife and I've never attempted to cut rubber gasket material. Um, I would imagine it would depend on the drag knife. If it's a 3D printed drag knife, I don't know. If it's something like the big Donek, maybe. But I can't say yes, no, or maybe. It's not something I've ever used, so I'm going to rely on you guys out here in the chat who have used a drag knife. Would it handle 1/8 inch rubber gasket material? Now, they advertise as being great for cork gasket, but I've never seen it used on rubber. That may be telling me something. But then again, maybe it's done all the time and nobody's bothered to film it. So, let's see. Dave Blackburn saying, what is your take on the master jig match fit clamping? I have never used it. So I don't know the first thing about it. I don't know what it's even for. Let's explore here together. Let's see. It's that master jig match fit. Master jig match fit. Oh, okay. I see what you're talking about. And we'll put it up here. We're talking about this kind of clamping, the match fit system. Where you have basically cut a series of dovetails into your spoil board or into a sacrificial spoil board, and using these clamps. I've never used them. And I don't know anybody that has used them on a CNC router table. I'm not sure. But I can tell you that this kind of clamp on a CNC table scares me to death. That's way too tall. This would probably be a better option. But again, I have never used anything like that. I tend to I use aluminum T-track and just quarter 20 bolts. But that's just me. I mean, to each their own. So um, basically, that was a long way to say I don't have a opinion on them because I've never used them. Okay, let's see here. Vortex 8, are there any online resources for doing math that anyone recommends? I'm not good and may need some help in the future. Well, what I would do, if depending upon what type of math you're talking about, what I would do is I would, you know, if without trying to embarrass anybody, okay? If you are self-proclaimed rotten at math and you think you need a refresher, you might reach out to your local high school and see if they can recommend a tutor. Um, if not, maybe check with your local community college and see can they recommend a tutor, or just check with your local community college and take some basic math classes. They have them. Most community colleges know that people like me in their 60s may need some refreshers and stuff like this, and they offer math, English, creative writing, things of that nature, all the way down to the basic level. I mean, you're not going for a university degree, but maybe a semester of math might be a good idea. But if you don't want to go that far, um, maybe a tutor to help you get the basics back down and just refresh our brains. I mean, we all can use a refresher every now and then. Um, I don't know anything about you, Vortex. If you have kids in school or grandkids in school, sit down with them and get them to refresh your brain. I mean, when it comes to math, I'm not the best at it. That's why I use calculators wherever I can. Um, and Brooks Martin makes a good point. YouTube tutorials are fine, but if you have a question, somebody right there with you is always going to be better off. I try to use calculators wherever I can because some things get driven into your head. Like I've been reading tape measures for oh gosh, 50 over 50 years. So some things, you see a line right here, that's a half inch, that's 11/16. I may be a little bit shaky on 30 seconds, but I generally don't use 30 seconds. I'm used to a 16th of an inch builder's tolerance. So, um, don't forget things like lynda.com or even Fiverr. I mean, you may find a math tutor on Fiverr that's willing to work with you for a low price. There are resources galore, but I prefer to check locally first. If your local high school knows of a high school student, if the math teacher has a student in mind, say, oh, yeah, this one's a whiz. This student of mine is an absolute math whiz, and they would make a great tutor. I mean, what high schooler wouldn't want to make a few bucks? So, um, but I would start local, just my opinion. If it's specific operations you need help with, like, converting a fraction to digital or something like that, or decimal, not digital. Come on, Mark. Um, use your software. I mean, it's uh, just about any, I'll use circle as an example, just about any fields here has a built-in calculator. Any field here, like on the diameter, has a built-in calculator. So to Bob Heltebridal's point, Google searches work for me to convert millimeter to inches and convert decimal to fractions. These calculators here will do the same thing. Like I can take this right now and I want a circle to have a 7 millimeter hole. But the job is set up in imperial. Well, I can enter 7 millimeters, then type in asterisk M, and then tap the equals button. Uh-oh. 177 inches? No, that's not right. I want 7 millimeters, Mark. 7 millimeters. Asterisk I for imperial. I want to convert that metric to I, imperial. Then tap equals, and that's 0.27559. So I don't even have to go do a Google search. I don't even have to do a Google search. Now, if I want that hole to be 11/32 in diameter, I can just go 11 divided by 32. And remember, that's what that line means, is divided by. So I have 11/32 there. I don't know what the decimal equivalent is. Type in equals, and there it is, 0.34375. So I use the built-in calculators all the time, even when I don't necessarily need them. Even when I'm not necessarily working in Aspire. I've got Aspire open all the time, sometimes 4, 5, 6 projects at once. Now, Brooks and Mike Healy, you all make a good point. Fraction calculator lets you type in multiple complex fractions and will give you an answer in fractions, helpful when using a ruler. Yeah, there are certain cases where that type of a calculator is very beneficial. I used to use a woodworker's calculator in the cabinet shop and the furniture shop, because when you have a whole bunch of different measurements, a calculator that will work in fractions, cumulatively speaking, comes in very, very handy. Because you got to add 11 and 3/16 to 4 and 5/8 plus 2.5 plus 1 and a 16th. It gets real cumbersome after a while. And yeah, you could do the math and go in and convert all of those fractions to decimal. But if you got a calculator that'll do that for you, bingo. And they're not expensive. And a lot of apps for your cell phone will do exactly the same thing. Maybe for $1 for that app, might be free if you don't mind advertising. But a woodworker's calculator is a good investment no matter which way you go. Now, this was back pre-internet, so we didn't have online calculators. But even something as simple as a Google search, Google has a lot of built-in calculators, and I use them all the time. That's how, when I'm talking to you folks here, that's how I know 5/1000ths of an inch is 0.127 millimeters. That's how I know a quarter of an inch is a little over 6 millimeters. I haven't got this memorized. I am totally dependent on calculators. If I want to know what 60 inches per minute in millimeters per second, I just type that in and it tells me 25.4 millimeters per second. Google has a lot of built-in calculators. So, I mean, yeah, you can find all these calculators, but I mean, if you want to know volume, if you want to know speeds, if you want to know um, measurements, um, 4 inches in millimeter, boom, there it is. Even something as simple as it's currently 70 degrees Fahrenheit in my shop, that's 21.1 Celsius. It's, you know, so yeah, um, Google is your friend and it will help you out. Now, to Eyal's point here, in Autodesk Fusion, for any length input, you could type 2 millimeter plus 1 inch. You know, I've never tried that. So let's figure it out. Let's see if that works here. I want to do a start length right there. And for my angle, let's go with 0 degrees. And for the length, let's go. I don't think I can type it in that way. I think what I'll have to do is both of those measurements have to be in the same unit of measure. I think if one of them is metric, both of them have to be metric, or if one of them is imperial, both of them have to be imperial. But you can kind of cheat that system by saying 4 millimeters. So I'll go times I equals. So now I have my imperial equivalent to 4 millimeters plus 3 inches equals, and then there's my total. So we'll add that, and there is my line. So there we go. So, okay, well, we got down in the weeds on that one. Vortex says, I think you should do a Sunday tutorial on the built-in calculators. I can do that. I have a couple of, I know I have one video out. It's really old. I mean, it's one of my first videos where I did talk about converting from imperial to metric and from metric to imperial. But it's one of the first videos I ever did. So you have to scroll way back. But yeah, point taken. I could do a tutorial on the built-in calculators. So let's see here. And finally here, Brooks asks, my question is, how OCD should I get when sanding? Say end grain. Can be tough to vanquish the ghosts. Saving the best for last. This is a topic that is so subjective. I look at it this way, Brooks. If it's got my name on it, I want it to be as perfect as I can get it. Okay. Having said that, style is also going to dictate a lot. I mean, if you want a rustic look, maybe you don't want to sand all that much. Uh, Maybe you want to leave some of those surface imperfections. And maybe you can tolerate, like, let's say you made a cutting board, an end grain cutting board, and you ran it through your drum sander, and you got out your random orbit sander and you're starting to clean it up. Maybe you find some of the sanding scratches left by the drum sander to be acceptable. I mean, we all get off the elevator on our own floor. So what looks great to me may not look great to you. Personally, I want to get rid of as much as that as I can. Now, I'm not going to get into the argument or the debate about running end grain through a surface planer. Some people say never, 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 ever do it. I've done it hundreds of times. You just have to be smarter than your planer. But I will never tell anybody to do that. And I will never tell anybody not to do that. But I will say we have a CNC router. And this is especially true if you're making something that's bigger than your planer anyway. Nothing will ever beat a well-tuned spindle or router, and I mean in tram, and a good surfacing bit. Now, hashtag not sponsored. I got this based on a recommendation by Shane Peters, and the way he put it to me was the best surfacing bit to get is the Amana Tool RC 2255. Now that's the half-inch shank. If you can't use the half-inch shank, then they do make a quarter-inch version, but it's a different part number. And I will go put a link in the description for this. It's not cheap, um, but it's worth it. I believe I did a short video on that Chaos end grain cutting board that I made for Linda. And I used this bit to surface after all the glue ups were done and everything. I used that bit to surface, and there was very, very little sanding to do on that end grain. I mean, it just it didn't even feel that end grain. Mount it to my table, surface it nice and flat, flip it over, surface the other side nice and flat. And on the show side, I made my final surfacing pass of 5 thousandths deep, which is that 0.127 millimeters. That's where that was coming in. That little teeny tiny bit being shaved off by this surfacing bit, it took me maybe 15 minutes with the random orbit sander and 220 grit, and then another 10 minutes, maybe, probably closer to 5 with 320 grit, and that cutting board was ready for finish. I mean, yeah, this is it's kind of using a Cadillac to haul manure. I mean, this is not a planer. It's pretty expensive to be using it as a planer. It's not faster than a planer by any stretch of the imagination. But I have to say that I've yet to find a better surface than with this. And sometimes things are just too big for the planer, or you don't have a planer. For those of you overseas, I'm talking about a thicknesser. And yes, Rob, I knew you were coming, um, and I was going to acknowledge this. Half the way in here, Shane and I use the RIP Precision Tools Slab Slayer for the last year and a half. We moved away from the Amana. When I bought this bit, I remember Shane telling me this when you both first came on that first live stream. He said, I've tried them all and this is the best. So I said, that's good enough for me. Now, that's not to say that since then, 2 years ago, something better hasn't come along. But for what I paid for this, I'm sticking with it. And I'm still on my original carbide cutters, and I haven't turned them. So, yeah, hashtag not sponsored. I will put a link to the RIP Precision Tool Slab Slayer down there as well. Let me write that down. Um,
Okay, so I've got some links to add. Um, yeah, and neither one of us are sponsored by them. So, yeah, it's new things come along all the time. But basically, Brooks, you know what you like, you know what you don't like. And I find it's easier for people to identify what they don't like. And if it looks good to you, it probably is. If it doesn't look good to you, it probably isn't. So, you know, vote your conscience. So, uh, absolutely, Wendell. You can mount rough cut lumber, surface it, and in fact, it's a good idea to do that when you're V carving, provided it's not plywood. But when you mount your material to your spoil board, it's nice to do a real quick finishing pass, surface it, then do your V carving. And that eliminates the problem of inconsistent material thicknesses and bits not carving all the way in as deeply as you thought it was going to be. So, all right. This was a long one. I will get the link to my two-sided playlist and to the Amana RC2255 bit and to the RIP Precision Tool Slab Slayer put into the description as soon as we're done with this live stream. Um, and I encourage you to play around with that vector offset tool. It really opened up my eyes a little bit on a few things, or not the vector offset, draw vector offset boundary. It really opened my eyes to a couple of things. And as Michael Mazalik said, it was featured in one of the early Vectric tutorial videos, but I don't see it getting a lot of mention. So it's something to look into. Channel members, remember, no members only live stream tomorrow. Where we have postponed that till Wednesday. So Wednesday, that will be January 3rd, 5:30 Pacific, 8:30 Eastern will be our members only live stream. Then after that, we'll go back to our normal Monday schedule. If you have no idea what the heck I'm talking about, or if you'd like some information on becoming a channel member, click that little join button down there. You're not joining anything, you're not obligated to anything. Just click it, and a little panel will pop up, and a video will play. You'll see my smiling face, and I'll tell you all about channel membership, the perks, the benefits. I got to tell you, it's a great community that's being developed over there. It's a lot of fun, and you guys are excellent. So, to my channel members, thank you for becoming channel members and thank you for staying channel members. For the rest of you, my subscribers, thank you for subscribing to my channel, for watching my videos, for participating here on Sundays, for sharing my videos, for sharing my content. Thank you very much. You all mean more to me than you'll ever know. And I appreciate every single one of you. What's coming up for next year? Can't really say. I've got a lot of projects I need to get done. I haven't worked in this shop for a couple of months. It's been that busy. I got to get back into it. I'm behind, way behind. But there may be some scheduling things that are a little bit weird and different, but we'll get into that a little bit later on in another episode. For now, let's just say have a safe night. Remember, the crazies will be out. I'm not going nowhere personally. I'm staying home. Let the amateurs go out there and do all the craziness. So have a safe, happy, prosperous new year and know that I appreciate every one of you. So, with that being said, um, go do something cool. Doesn't matter if it's in the shop, if it's a card game with your better half, doesn't matter. Just go enjoy for the day and recover tomorrow. And I'll see y'all next week. Thank you very much. Y'all take care.